All right, guys. So in this section, 6.5, we're going to talk about what are called areas of composite figures. So a composite figure is a figure that is able to be divided into regions that are more simple shapes. In other words, a composite figure is one that really doesn't have a shape of its own, but you can divide it into shapes that we're familiar with. So you can break it apart into triangles and parallelograms and trapezoids and so on. So when you want to find the area of a composite figure, you basically find the area of each of the individual shapes that make it up. So in other words, you divide the figure into regions that are basic shapes, find the area of each region, and then in step 3, just add all of the areas together to get the total area for the composite figure. In other words, you're just breaking it down into smaller pieces, which are easier to manage, and then just adding them all together at the end. So let's take a look at some examples. In each of these examples, we're asked to find the area of the shape and round to the nearest tenth when needed. Okay, so in this first one, it's kind of already set up for us. You can see that there are two basic shapes. You've got your rectangle right here, and then you've got your trapezoid right here. And we're basically looking for the area of those two shapes. So I'm going to call those shape 1 and shape 2. Let's let the rectangle be shape number 1, and we're going to let the trapezoid be shape number 2. So to find the area of our rectangle first, so our shape number 1, remember the area for that is to take your length multiplied by your width. And so in this case, our length would have to be that 23 right here, and our width would have to be this 12 right here. So for the area of the rectangle, we're going to take our length of 23 multiplied by our width of 12, and that tells us that the area of our rectangle is 276. Now, for our trapezoid, remember our area for a trapezoid is to take base 1 plus base 2 over 2 multiplied by your height. So let's figure out kind of everything that's going on. We can go ahead and let the 15 be our base 1. For base 2, we need this length right here, which is going to be the same as this length of a rectangle right here. So that's going to be 23 centimeters. So that's going to be our base number 2. As for the height, we need to figure out what this distance right here would be. And to find that distance, we know that the entire length is 18. We know that this piece of it right here is 12. So if we take 18 minus 12, that tells us that this length is length 6. So then if we plug those into our formula for our area of our trapezoid, then base 1, which we said was 15, plus base 2, which we said was 23, divide by 2, multiplied by our height, which is 6. And again, I would just recommend putting that into your calculator. It ends up being an area of 114. So we've got the area of our first shape, which was our rectangle, and that is 276. We're going to now add our area of our trapezoid, which is 114. And when we add those together, we end up with a total area of 390. Looking at our label, it was centimeters. Remember, for area, that becomes squared. So the area for our entire shape is 390 centimeters squared. All right. In this next example, once again, we've got kind of two shapes. We've got our semicircle, which I'm going to go ahead and just call that shape A. And then we've got our triangle, which I'll call shape B. So, starting with our semicircle. Remember, the area for a semicircle is pi r squared multiplied by 1/2, since a semicircle is 1/2 the area of a full circle. Now, our R value is not going to be 16. 16 is the entire length of the diameter. So the R value is going to be half of that, which is 8. So we're going to have pi multiplied by 8 squared multiplied by 1/2. And when we simplify that, 8 squared is 64, and 64 multiplied by 1/2, or 64 divided by 2, is 32. So the area for our semicircle is 32 pi. Now, for our second figure, for our triangle, the area is going to be equal to our 1/2, our base, multiplied by our height. Now, in this case, looking at your triangle, we know our base, which is the entire length, which is 16. So area is 1/2 multiplied by 16. But the height of our triangle is actually this distance right here. And we don't know what that distance is just yet. In fact, to find that, we're going to have to do something that we would have done in a previous unit. In order to find that height, notice that we have a right triangle with one missing side. This is where we're going to want to use the Pythagorean theorem in order to find the length of our missing side. So remember, Pythagorean theorem is that a squared plus b squared is equal to c squared. And so we're going to let a be 8, so that's 8 squared, plus b is our height, so h squared is equal to c, which is our hypotenuse, and that's 17 squared. So when we simplify that, 8 squared is 64, plus h squared is equal to 17 squared is 289. So now to get h squared by itself, let's subtract 64 from both sides. And that's going to give us that h squared is equal to 225. And now take the square root of both sides. We're going to find out that h is equal to 15. So for our area, we already had part of it filled in right here, which is the area is equal to 1/2 multiplied by the base, multiplied by our height, which we now know is 15. And now we can go ahead and simplify that. Again, I would probably just type that into my calculator. 1/2 multiplied by 16 multiplied by 15 is 120. So now to put those both together, if we want to find the area of the entire figure, we're going to take the area of our first piece, which was 32 pi, plus the area of our second piece, which is 120. Now in this case, because one part has pi, the other part does not, then if we're going to leave our answer as an exact value, we would actually type it in like this. We would type it in as 32 pi plus 120. Just make sure to include your label, which is meters squared. But it did ask us to round to the nearest tenth whenever we needed to. So we'll go ahead and type this into our calculator. It ends up being that this is about 220.5 meters squared. All right, let's take a look at a few more examples. So in this next example, we've got multiple parts to this example. Let's go ahead and label each of those. Let's call our square part A. We'll call our trapezoid part B. And we'll call our triangle over here part C. All right. So starting with our area of the square, we really want to know kind of what is our total length of our square. Well, what is the side length? And that's going to be probably the most important part of finding this. But in order to do that, we really need to figure out what the lengths of our triangle are first. We need to figure out what are our lengths right here. I'm going to call that x. So in order to find that, we're actually going to have to do a little bit of Pythagorean theorem once again. We know that our length of our height is 5 centimeters. We were told that right, or 5 meters. We were told that right here. And the length of our hypotenuse is 13 meters. So if we set up Pythagorean theorem, which remember, we go ahead and take a squared plus b squared and set that equal to c squared. Then let's let a be our 5, so 5 squared. We're going to let b be the variable, so x squared is equal to c, which is our hypotenuse, and that's 13 squared. All right, so now simplifying that, 5 squared is 25 plus x squared is equal to 13 squared, which is 169. So now solving for x squared, we're going to go ahead and subtract by 25 on both sides to get that x squared is equal to 144. And now to get x by itself, just take the square root of both sides of the equation, and we'll find out that x is equal to 12. In fact, I'm just going to go ahead and erase x just to make it a little bit easier to read and call that 12 right here. Now, if that length is 12, then since these two triangles are the same, then that tells us that this length is also 12, which means the sides of our square, if we take 12 plus 12, tells us that this length right here has to be 24, which also means that this side, since our two sides were congruent, also has to be 24. So now we can go ahead and find the area for that square. Remember, the area of a square is to take your side and square it. In this case, our side is 24. And when we take 24 squared, we get 576. Next, let's go ahead and find our trapezoid. So remember, for our trapezoid, which is our second shape B, we're going to take base 1 plus base 2, divide that by 2, multiplied by your height. Now let's go ahead and let base 1 be the 10 meters that we already had. For base 2, the base that's missing right now, but remember that that has to be the same length as the other sides of our square. In other words, base 2 is going to have to be 24. And then for our missing height, we need to know what this distance is right here. Well, we know the length of the entire distance is 37. We know that this piece is 24. If we take 37 minus 24, we can find out that our height is going to be equal to 13. So putting those into our formula, we're going to take our base 1, which was 10, plus base 2 is 24, all over 2, multiplied by our height, which is 13. And again, I would recommend just putting that into your calculator. We're going to come up with the area for our trapezoid being 221. Finally, for the area of our triangle, remember we're going to take 1/2 our base multiplied by our height. And so for our triangle, that's going to be 1/2. Our base was actually both 12s put together. So if you take 12 plus 12, then our base was 24. So 1/2 multiplied by 24, multiplied by our height, which was 5. So now putting that into our formula, we're going to go ahead and simplify that and typing that into our calculator. We're going to find out that the area of our triangle is 60 degrees. Or not 60 degrees, just 60. All right, so now to find the entire area, remember we're just going to add everything together. So that's going to be the 576 for our square, plus the 221 of our trapezoid, plus the 60 from our triangle, which adds up to be a total of 857. In this case, our label was meters m squared. All right. So that one was pretty tough, but we were able to figure it out. This next one's actually quite a bit easier. So if you're wanting to try one on your own, this would be a good one to do that with. In order to find our area for this figure, notice that it's actually not divided up for us. We're going to have to do that on our own. We've really got two choices for how to do that. We can either break it apart this way into a square and a rectangle, or we can break it up this way into a square and a rectangle. I'm going to go ahead and break it up the second way. And again, it doesn't really matter which way you choose to break it up, but let's go ahead and pretend like this was a side right here. And we've got our two figures then. We've got figure A, which is going to be this rectangle, and figure B, which is going to be this square. All right, so for the first one, for figure A, our area of our rectangle is equal to our length multiplied by our width. Let's let the length be 4, width be 6. So our area is going to be equal to 4 multiplied by 6. So the area for our rectangle is 24. For our second figure, for figure B, our area of a square is equal to our side length squared. So to find the length of our side, probably the easiest way to do that is to think about the entire length of this rectangle being equal to 6. Since our two sides with these two tick marks are congruent, that tells us that this piece from right here to right here is a length of 4, which means that the area, or for the length of our side, if we take 6 minus 4, tells us that our side length here is 2. So the area for our sides of our square are length 2. So our area for our square, if we take our side and square it, that would be 2 squared. And 2 squared is equal to 4. So for our area of our entire figure, we'll add those together. 24 plus 4, and that adds up to be 28. And our label in this case was centimeters squared. All right, let's take a look at one last example, and then we will be done for today. So once again, just like in the previous example, we're going to have to divide this figure up into some smaller shapes. It wasn't already done for us. One shape should be pretty clear, and it's going to have to happen, which is we're going to have to divide up this semicircle. I'm going to go ahead and draw that in right now. So that's going to be one of our shapes. And then for our other two shapes, again, we've got some choices on how to divide those up. I'm going to go ahead and split them up by making two rectangles. So I'm going to draw in the line right here. All right. So now remember, if this side length is 5 right here, then anywhere else that has that one tick mark is also length 5. So I'm just going to draw in a couple more 5s in those two spots as well. So let's talk about our semicircle first. So let's talk about shape A. Now, in order to find the area for your semicircle, remember the area for a semicircle is to take pi r squared multiplied by 1/2. So really what we need to find is our radius. We should know what the entire length of our diameter is. That would be 5 plus 1, so this entire length is 6. So if we want to know what the length of half of that is for our radius, just take half of that, which half of 6 would be 3. So then our area for our semicircle is equal to pi multiplied by 3 squared multiplied by 1/2. As we simplify that, 3 squared is 9. So our area is equal to pi multiplied by 9 multiplied by 1/2. Which 9 multiplied by 1/2, it's not going to simplify because you can't take 9 and divide by 2. So we'll just leave that as 9/2 multiplied by pi. Next, we'll go ahead and find the length or the area for our rectangle right here. So for that rectangle, our area is equal to length multiplied by width. We're going to go ahead and let length be 5. Now the width is not also 5 because notice that although there is a 5 right here, that's not the entire distance. Our width is actually going to be this 6 right here. So that's going to be an area of 5 multiplied by 6. So the area for our rectangle, our first one, is going to be equal to 30. Finally, for our last shape, which I will call shape C, that area is also equal to length multiplied by width. This one's pretty straightforward. We'll just let length be this 5, width be 1. So that would be 5 multiplied by 1, and that's an area of 5. So now to find the total area, we're just going to add all those together. So that would be 9/2 multiplied by pi plus 30 plus 5. And as we simplify that, at least at first, we're just going to combine our like terms. So we're going to put the 30 and the 5 together. So that would be 9/2 pi plus 35. And so again, that would be the exact answer. So that would be what you'd be typing in as your final answer. But as far as rounding to the nearest 10th, because it did ask for us to do that, it ends up being about 49.1. Now, don't forget your labels. That would be centimeters squared, and there would be our final answer. All right, guys, that is all I've got for us today. Until next time, have a great rest of your day.